All right. So let's take a look at this one. This one's a bit of a doozy. We've got one logarithm. We've got the brackets here because we've already got parentheses on the inside. We've got quite the product going on up here on top. We also have a product on the bottom. We've got this power here. X plus 7 squared is a power being multiplied by 3. We've got this cubed root here. So the first thing I'm going to do, kind of crudely, is take this binomial 5 minus x that's under that radical and raise it to the 1/3 power. Now, when you consider everything that's inside the logarithm, we don't have an exponent for everything. So we're not going to drop anything down in front of this. We're going to look immediately on the inside and see that it is one big ratio, one big fraction. So we're going to take that, we're going to separate it into the difference of two logs. Okay, so we have log, worth noting, no base, right? So that's base 10. We call this common log. And then we have this rather large product in here. It looks horrible, okay, where we have 100 x cubed and then 5 minus x to the 1/3 power minus, and then we have our denominator, okay? Now, what I'm going to choose to do here is I'm just going to address the first logarithm and expand that completely, and then we'll look at this other one here if that's okay with you guys. So inside this one logarithm, there is a set of parentheses, but all of this is being multiplied together. So really we have 100 being multiplied times x cubed because they're pushed together, and then we have that with the parentheses here. So this is a product that has three separate factors, right? So what we're going to do is we're going to take each one of those and assign them each to their own logarithm, where we turn this into a sum instead of a product. So we have the logarithm of 100 plus the logarithm of x cubed plus the logarithm of this quantity raised to the 1/3 power. Then, like I said, if it's okay with you guys, I'd rather just leave this one alone for right now and only look at that first logarithm and do what I can do here, work my magic, and then we'll come here and address what we have on the back end. So the first part here has log of 100. Keep in mind, as I said already, that this is log base 10. Okay, so this is not a product, it's not a quotient, it's not a power, but I can evaluate this logarithm, right? What power do I raise 10 to get 100? And the correct answer to that would be 2. Then we come to the next logarithm. Inside this logarithm, we do have a power. So I'm going to take that 3 and move it in front of the logarithm. So now it's 3 log x. Okay? Plus, we look inside this logarithm, and again, we have a power. So that 1/3 is going to come down in front of this log. Now, mentioned this in class. I'm going to mention it again here. The parentheses here are very important. Okay? We have to keep the parentheses because this was being raised to the 1/3 power. 5 minus x is still inside that logarithm. Okay, and just as a brief aside, we mentioned that log of 5 minus x is a different statement than log of 5 minus x, right? And we want that 5 minus x to stay inside that logarithm, so we have to keep the parentheses around that. Those are crucial to telling us what's actually inside this. In this statement, the 5 is the only argument in that logarithm, and then it's just a minus x tagged on the back end. But we want the 5 minus x in there. Okay, so this is the full expansion of that numerator. Now let's look here, okay, because things get a little interesting here on the back end. Now this is the log of a product, right? So this 3 is being multiplied times this quantity. The 2 that's here is not an exponent for everything inside the log. So I am not going to put this 2 in front of this logarithm right now because it only applies to what it's touching, and it's only touching the parentheses. But what does happen here is this logarithm, because it's a product, I have to separate that into the sum of 2 logs. Okay? But because I am subtracting this logarithm, you have 2 ways to think about this. This logarithm is going to become, and I'll write it small, it's going to become log base 3 plus log base x plus 7 squared. But because this logarithm was being subtracted, I have to subtract, and maybe I should use a different color here to emphasize this. I have to subtract all of its offspring, for lack of a better word. Okay, because this one logarithm is being expanded into two, and because this one logarithm was being subtracted, I have to subtract both of these logarithms. So that's going to look like this: minus log base 3 minus log of x plus 7 squared. So really, this logarithm does become a sum, but that sum, both of these terms become negative because that first logarithm was being subtracted. Okay, so hopefully that makes sense. You see that when we're expanding a log that's being subtracted, we have to subtract all of them. Okay, and we saw that with was it this example? Okay, where we said the 1/3 was being applied to this logarithm, so all of its offspring get that 1/3. Okay, both of these got that, and then when I expanded this, they both got the 1/3 as well, as long as that's in front of it. Sorry. So we have, so we have this statement. We still have the 2. We said that these first few logarithms are complete. There's not much I can do here. There's not anything I can do here. All right. Now we have the common log of 3. This is log base 10, but I don't know off the top of my head what power I could raise 10 to get 3. So since I can't actually evaluate that and get an integer, I'm just going to leave it. And then we lastly look at this last logarithm. This is a power. So that 2 is going to come down in front of this logarithm, and I have to keep that x plus 7 in parentheses for the exact same reason we were mentioning that here. Okay, last check. This has already been evaluated. No products, powers, or fractions. 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 That's as good as that one's going to get. Kind of a beast, right?